Hi, John Lieber here with the Solidworks 2019 deep dive video for Solidworks PCB. And the great thing that we have to share with you is actually going to start off with our mechanical oriented workflow. So instead of starting here in the PCB tool, we're actually going to start inside of Solidworks. So by switching over here to Solidworks, we are going to start by creating a brand new project here in Solidworks. This isn't new, we've been able to do this, but since we're focused on the mechanical oriented workflows here in the first part, let's actually call this our Mo board or Mo PCB. And for the description, we will just call this our mechanical workflow. Alright, so ultimately I am creating a PCB project for use in SolidWorks PCB and for use in SolidWorks. So the first thing that comes up is to ask me where I want to save my top level assembly. We're going to create a new folder, call it the Mo PCB, and give it a name of Mo PCB SolidWorks Assembly. And this is going to create my board inside of SolidWorks without ever actually creating anything inside of the PCB project yet. And we're presented with a basic board, and here I'm just going to make a couple adjustments. Nothing spectacularly new, but a few things that I want to kind of share with you here that I won't say is frustrating, but as a SolidWorks user, I like dimensions. So I'm going to add a couple things here. We're going to round off the corners and add some dimensions to the board. So to round off those corners, we're just going to actually highlight the four edges, tell it we'd like these to be 0.25, hit the checkbox, and let it go from there. Once I've done that, we'll go ahead and use my fancy S key and ask SolidWorks to fully define the sketch for me. So I just typed the word fully, hit the enter key. At this point, we'll hit calculate, and I'll get my board dimensions. Here we'll change the dimensions to say we want this to be 3 inches by 4 inches. Now the reality is the board I want to create is actually only 2 inches by 3 inches. But the way this works is inside of SolidWorks PCB, when I create a new PCB document, the board doesn't actually start at the 0 point in the assembly or in the PCB document. It starts about an inch away. So that's the way the board was created inside of SolidWorks, even though I started in SolidWorks. At this point, I can do the math and figure out, well, this needs to be 4 by 3. But what I'm actually going to do is just reassociate the dimensions to the appropriate edges of the model. So I'll just click the 4 and the 2 inch dimension, drag the association handles here. And now I have my 2 by 3 dimensions, and I got my 1 by 1. We might change that later, but for right now I'm actually going to leave that here and go back into my top assembly, make sure I save everything, and shoot it over to our ECAG user who may want to throw a couple mechanical components on there for me to place while I'm actually adjusting the rest of the board cutouts and such. So board shape, we'll put a little note here, board shape defined, and throw this over to the PCB user. Now as the PCB user, I'm going to switch back to PCB, and instead of saying create a new project, I'm going to say open a project, and then we are going to get our project manager, and just use my little keyboard shortcuts. Here's Mo PCB, open that up, and what I do need to do is add a PCB document. So we'll right click and say let's add a PCB document. And a good user, I will save that PCB document, and we'll just call it PCB1. Now, once that PCB document is created inside of SolidWorks, I'm going to go to my View tab and select SolidWorks PCB connector, and you'll see immediately it says, okay, hey, someone's modified the board shape. I can view those changes by clicking on the board outline here. That's the only change at this point. And I can see here that the board shape's changed. I'm going to accept that change and hit accept. And then I'm going to actually switch over to my schematic as a ECAG user, maybe start building out the schematic with the mechanical components. While that's happening, I'm going to actually switch over to SolidWorks and add a couple critical pieces here. I need some board cutouts and some holes for mounting. So switching back to SolidWorks, let's just minimize this. I'm going to select the board, say open this guy here, and make some holes in here to start off with. So we'll create a new sketch. Now this isn't really new as far as the PCB is concerned, but what I did want to point out here is I'm going to actually create 4 holes by referencing the center point of the rounded corners that I placed in here earlier. So here's my 4 holes. Number 3 and number 4. All right, so after I've got those 4 holes, we'll just add some relationships to say they're equal, and then add a dimension to define the size of those holes. We'll say they're 1/4 of an inch in diameter. So pretty big holes, but we're pretty happy with that. And the key thing here is the fact that I've created one sketch and placed all 4 sketch pieces of sketch geometry into the one sketch. In previous versions, we'd have to do this as multiple cuts. In this particular case, we're going to just throw all 4 into one sketch, create that cut there. We could actually do this with our linear pattern tool, so we could actually create maybe a series of holes along the edge here. And the fun part here is we can actually use the hole wizard to create those holes. So we can use quite a few new features of Solidworks. Now, they're not necessarily new features to Solidworks, but they're new features as far as how we can actually manipulate this board here inside of Solidworks. In this particular case, I just want to deal with the 4 mounting holes. So we'll go ahead and save this assembly. Maybe go back to a shaded view. Go back to the top level assembly here. And push these changes over to Solidworks PCB. So added the holes for mounting only, and we'll send that off to the Solidworks PCB. Now, if I switch back to Solidworks PCB, you'll see the Solidworks PCB user has actually created a schematic sheet, added a couple mechatronic components, a USB port, and DC power port. So at this point, we'll push those changes through our ECO process into the PCB layout. And before I actually deal with these guys right here, I want to go ahead and check to see if anything's happened on the mechanical side. So I can view those changes here. You can see it's created the cutouts. All 4 of those, so we'll accept those cutouts right here. Oh, I hit cancel, so we'll pull those changes again, and this time we'll hit check all and accept those. So those will add those cutouts here. Now, what's kind of interesting here is in SolidWorks doesn't really understand the difference between a plated hole, non-plated hole. So I can actually go in here and look at these cutouts, and if I wanted to, I could lock these into position, which would actually prevent the SolidWorks user from moving those. Or I can actually go in and add these as a via, or change these to via types and add things like plating information. But now that I have my mounting holes, I'm going to go ahead and simply move my mechatronics components in here. Maybe I know I need to change the direction. Maybe we'll go to 3D so I can see what's going on here. So that looks pretty good to me. And I want to send this back over to the mechanical person to make sure these get aligned exactly with the cutouts in the enclosure, or just simply have them add some dimensions to accurately place these. So here we'll go ahead and go back to the connector settings. We'll push these back, added components, hit post. And once that's posted, we'll switch over to SolidWorks. And you'll see here, as soon as that gets done posting, it will show up as a note. So there's my little note there. We can view those changes. So it's going to go through and adjust all the pieces that need to go here. In this particular case, I'm looking at my overlays. These are new to SolidWorks 2019. And ultimately what's going on here with these overlays and the 2 components, we'll accept that, is when I go into place components in the PCB side, we have silk screening, we may have some copper traces, and that information will actually now appear inside of SolidWorks. So you can see if I rotate this board around, maybe change the lighting a little bit, you'll see that I have the copper information as well as the silk screen. So I know this component here is J1 and this is J2. So here's my board. It's now sitting inside of Solidworks, and I'm not happy with the ECAG user because he put those on the top of the board and they actually should be on the other side of the board. So I could in the past send an email or walk over to the cubicle and say, hey dude, these things need to be placed on the other side. But what's great here inside of SolidWorks 2019 is I can actually right click on the components in question, go to the PCB add-in and select flip component side. Now what this is going to do is it's going to flip the components over to the other side. The silk screens actually need to be updated on the PCB side. So now that they've been pushed over or flipped over, we'll go back here to our PCB side and we'll hit push. Moved components to the other side and hit post. So that's going to post that over here. We'll switch back to our ECAG user. The notification is immediate here. We can view those changes. So it's saying, okay, these have moved over, and we'll just right click and accept that. So now we know those have moved over. I can look at my 3D view, see, okay, yep, they are truly on the opposite side of the board. And maybe this component right here needs to be moved around a little bit again, so we can click on this guy, start moving them, and say that's where they need to go. So we'll save this board again, push this information back to the SolidWorks user. Okay, looks good now. And we'll get those changes over to the SolidWorks user. Now, going back to the SolidWorks user, we have a couple things here. We'll review the changes. We'll take all the layers and the components and accept those. So we'll go through and place some checkbox here. And you'll see here it'll actually update the silk screening so that they're on the other side. Everything's moved. And everything looks great. So if I rotate this around, I can see here my silk screen's been updated, the copper has all been updated, and inside of SolidWorks I can now look at the more specific pieces of information here that I want to see. So let's go to the back side of the board, and as I start manipulating these, I might notice that there's a keep out or something. For some reason, there's a specific purpose or specific reason I cannot place this component in a certain area. And based off of my mechanical pieces, maybe I'm going to put a big hole here at some point, but I'm not really sure how big that is. So what I can actually do is we'll create a new part in context of the assembly. We're going to call this keep out 1. And we'll place that guy here on this back side. And I'm just going to create a little sketch. So we'll do that. Maybe add some rounded areas here. We'll make those equal relationships and add some dimensions. So this will be an area of about 1 inch by 0.5, and then line these up with the center of the board. I'm just going to create a center line from the center point here to the center point of the board and say make that line vertical, and then maybe do the same thing on the center here. So we'll come in here and say let's do this and make him horizontal. All right, last piece here is to give these guys a dimension, so we'll say 0.25. Let's make them a little bigger. Let's make them 1/2 inch. So I'm pretty happy with that. We'll trim out the geometry. So in here. So that's pretty good. Pretty happy with this, and we'll extrude that. and it needs to be at least a little bit bigger than the components. So I'm pretty happy there. And I've got this new part in here called the keep out. And the great thing about this is now when I push this over to the PCB user, we'll added keep out, post that over here. That block is actually going to show up as a free body in PCB. So here we'll review those changes. It's added the keep out. And if we shoot over here to 3D mode, you can see that keep out has been placed into my PCB. The reason why this is important is if I choose to move these things around and I place the component somewhere in that keep out region, you'll see how my design rule check is actually telling me that I have a violation here. I'm violating my keep out area. So being able to define that inside of Solidworks is super helpful because we can add our dimensions, we can line it up with the exact centers of the board, and when I send that over to the Solidworks PCB, I can use that to maintain height clearances, or if there's an area of the board that I can't place components in, I now know where that area is without having to maybe review a DXF or a DWG or something like that. So we're going to go ahead and make sure those are not violating my keep outs. And another new feature here is right now I'm actually able to move these components around. And as a Solidworks user, I may have gone in and added some mate information to say this is the exact location. Maybe place some mates in here to say this has a specific distance of 0.8. So we'll leave that there. But once I get in there and do this, I don't want the Solidworks PCB user to make any change to this, even if it's by accident. So one of the things I can do inside of SolidWorks 2019 now is if I go to that component properties, right click on it and select this fix command. So that's going to fix it here inside of SolidWorks. So I can't click on that and move it. But when I post this back to the SolidWorks PCB user, final positions, please don't move. In the past, what I have to do is just kind of hope that they don't move it. When I come back into SolidWorks PCB, it's going to see some changes here. So we'll go ahead and just accept these out here. So right here, this is the one that's important. It's multiple 2 component here. And what that's actually telling me is if I go to the component properties, this component has now been locked, which simply means that I can't move him by clicking on it and dragging it. I can move any of the other components that I may have added, but I can't move this component. Okay, so before I forget, another thing that is kind of cool here with the fixing of components is if I fix the component here or lock it here or unlock it inside of SolidWorks PCB, that information will actually travel back over to SolidWorks and unfix the component so it can be moved around. So if I, let's say I decided this component does need to be moved, I can kind of signify that by going to the component properties, unlocking it and pushing that back with a little note that I need to move this component. Now, while we were doing all that fun stuff over in SolidWorks, I was updating the schematic here for the USB. So here's my little control circuit for the USB. And let's go ahead and push those changes back over to the layout tool. So we'll just execute those changes here. Now, one of the things I really like about SolidWorks PCB here is it is actually running some design rule checks and giving me some indications and warnings. In this particular case, I'm not dealing with class members, so I can safely ignore that. And I can actually go into my settings and tell it not to give me any error messages or warning messages about class members, since I don't really deal with those here. I can also ask it to report on those changes to create an Excel spreadsheet document here that I could maybe place into SolidWorks PDM so I can keep track of these changes as I'm actually going back and forth. But now that my components are here, we're not going to go through and place all these in here, but I do want to show you a couple really kind of neat functions here. We'll throw maybe these guys up here. You'll see I'm getting my online design rule checks. Let me know if I'm overlapping my holes or violating any other kind of rules in here. So we'll place the rest of these maybe up in here. Surrounding, we're not really paying too much attention to good design here, but we'll get these guys in here. So we'll get them placed in here. And I know a lot of you really, oh, that one's a little bit too close to the edge, so let's go ahead and just flip this around and move him over here. All right, so I know the arguments on the auto routers, but for our purposes right now, we'll go ahead and use my auto router to go ahead and route all the traces in here. So it's going in and adding any vias that are necessary, placing the traces, all based off of my design rules. But now that I have the rest of these components in here, I'm going to go ahead and save this board. We'll save the project, good practice there, and then we'll push these changes back to the Solidworks user. And this is where I'm going to show you a couple of things that are new here. So we spent a lot of time, more components, we've added more components and traces. And as that's pushing through here, inside the PCB tool, if I go to the 3D view, I'll see those traces and all the silk screen and all that kind of fun stuff in here. So let's go look at this, and you can see I've got all my traces going on. All that fun stuff is happening here. And we just kind of miss out on that on the SolidWorks side. So you can see I've got traces on the top and the bottom based off of where the components are. So let's go back over to SolidWorks. SolidWorks has noted that we've made some changes. Before I do that, I'm actually going to just hit the tab key to hide that because it's there for keep out. Right now I don't need to see it. So we'll go back here, review the changes, and we'll just accept everything out here. And we'll get to see some magic happen here. This is something that's been requested. It's probably one of the most requested features, other than being able to see the silk screens in the SolidWorks assembly. We can now actually see all the traces. So as we flip back here to SolidWorks, you'll see inside of SolidWorks, new traces have been added in here. So those are all the traces. They do show up on both sides of the board. So there's all my components and all my traces, and that should make a lot of people pretty happy because now if we're adjusting our housing for maybe test points or something like that, that information is now being carried over from the PCB tool into SolidWorks. Yeah, so we have the ability to bring in the traces, the silk screen, the components. We can now change the component side here inside of SolidWorks. We can add our cutouts and holes using things like the patterning tools. So what else have the folks over at SolidWorks given us? So as I go in here, these traces are actually images. If we open up the board, you'll see we have decals. If I come in here, I've got my board color, and I've got a bunch of decals that have been assigned to this board. So if I look at this board in shading mode, all these right here, all these traces are actually decals. So what we're actually getting at here is we don't see any kind of performance hit because we've added these traces into our assembly. We're always being aware of the performance of your SolidWorks parts and assemblies. And even though that we're adding the traces here, in this particular case, it's not a lot of them, but sometimes there'll be thousands and thousands of traces. And by creating these as decals, we don't see that performance hit as if these were solid bodies. Now, if you do want to bring these in as solid bodies, if we go to our SolidWorks options here and look at the settings, you'll see the model copper collaboration option right here. We have the ability to turn that on or off. If I'd switch this to on and pulled that board in, all those traces would actually come in as solid bodies that we could use, for example, in a thermal analysis or any other purposes that you can think of. Now on the PCB side, we did add a couple new capabilities here. When we're looking at our board layout, switch over here to 2D view, flip to the outputs. We now have the ability to export this out as a VRML, so we could actually directly send this to a one of the, let's say, Stratasys printers, as well as CST and DXF-DWG format. So we can actually just, from right here, create a DWG file of the board for use in other applications, for example. And inside of SolidWorks, of course, when I bring these components over, all the information about the components, all the component parameters that were defined in SolidWorks PCB will actually be defined here in the properties of the SolidWorks part. So you can see if it's a mechatronic component, the color, all the information about this. Then this can be used in the bill of material, in drawings, that kind of fun stuff. But what I found most interesting here is enhanced search capabilities. So here I am inside of SolidWorks, and I know I have a component J2 that may need to be moved or something like that. So what this allows me to do now in SolidWorks 2019 is I can go to my Feature Manager filtering tool and type the component number, so component name, J2, and see here I have a component called J2. It's right over here, and a component called J20. So that's sitting over here. So as I'm actually going through, I can actually filter my SolidWorks Feature Manager for specific components and use that information in here. We could add like a parameter that says like it's a red LED, and if I had a red LED in here, I could type the word red, and you see D7 and D6 are actually red LEDs. So we can actually search inside of SolidWorks based off of the parameters that are defined in the SolidWorks schematic component parameters. So that's what we have here for the new enhancements for SolidWorks PCB. As you can see, it's not just SolidWorks PCB that we're enhancing, but the capabilities inside of the SolidWorks mechanical tool that really give us a much tighter, seamless integration between the two applications, as well as new functionality. Well, thanks for listening to our SolidWorks PCB 2019 deep dive. And of course, if you have any questions, please do not hesitate to reach out to us here at GoEngineer.